slides, by the way, are in the, you'll find them in the handouts, so you can go and have a look at that. But I'd rather introduce you to two very important people. Oh, can we go back? One of them's Carol Patak and Chad Smith, and these are the two partners in the Demand Driven Institute. And just very briefly, Carol comes out of manufacturing in the aircraft industry, in the aircraft component industry. She worked for IBM and later on worked for PeopleSoft. She comes out of planning and materials management, and she always thought that planning on forecasting really wasn't the right thing to do because we start off with the wrong numbers. And so at PeopleSoft, she started working on a demand-driven manufacturing system. And they were just about to launch it in about 2006, and there was a hostile takeover of PeopleSoft by Oracle. And Oracle canned all the work they've been doing on this demand-driven, basically demand-driven MRP. So Carol left and went off and became a professor at a university for a while. She knew Chad Smith, and Chad comes out of the theory of constraints stable, working with a company called Constraint Management Group. And he knew Carol fairly well and came to see her and said, I've been working on something demand-driven. I've always felt it's a bit crazy that we plan on a forecast. And Carol said, well, that's exactly what we were doing at PeopleSoft. So they came together, worked together to form the Demand Driven Institute and put this methodology together. So this is nothing new. This goes back to way before the turn of the century. So there were people before the turn of the century that were adopting this methodology and proving it. They're also great authors, and you can see a lot of books in front of you there. All right, next. So materials requirements planning has been the way of life for us over a number of years. Next. You can click through this one, Elaine. Okay, so it really came to the fore with Joe Orlicke writing his book, Materials Requirements Planning, which was published in about 1975. And what did MRP promises? It promised time phase planning, level by level bomb explosions, dependent demand planning. It also gave us some benefits in those days, component synchronization, reduction in inventory, and improved priorities. And in his book, when he published it in 75, he said there were about 700 manufacturing companies that were adopting this methodology. Next. So MRP became the way of life for planning. It was conceived, can you go back? It was conceived in the 50s. And can you just go back there, Elaine? No, go back, not forward. Yeah. It was conceived in the 50s. We knew in the 50s that if we had a bill of materials and we knew, say, for a bicycle, and we knew how many bicycles we wanted to make, we could calculate through a bill of materials how many components and raw materials and things we needed, which was fine if we had one finished product and 6 raw materials. You can do it on a piece of paper. But with hundreds of finished products and thousands of raw materials, it was a little bit more difficult. We didn't have the tools to be able to do that. And it was only around about the middle of the 60s that we started to getting computer systems that were powerful enough to do the thousands of calculations that we needed. And there was a guy called Richard Ling at IBM, who wrote the very first algorithms for materials requirements planning. And those algorithms haven't changed since Dick wrote them way back in 1965. And it was only about in the 70s when it was commercialized. And probably by the 1990s, most manufacturing companies or companies had some form of MRP system implemented. I put my first one in about 1988, I think it was. And we were quite successful. It worked quite well. Okay, next. Next. Okay, but I think since then things have gone kind of terribly wrong. Most planners and buyers mistrust their planning systems. If I ask people, do you believe what your computer system's telling you, they generally say, no, not really. And so we've developed lots of spreadsheets that become rampant and often unmonitored. And these spreadsheets have limited capability, scalability, and transferability. And even the Aberdeen group, who sort of categorize companies as best in class and average and laggards, even best in class companies are saying that over 60% of them are using spreadsheets to help them with their planning. Again, line. So they're also very error prone, these spreadsheets. In fact, there was some work done by the Wall Street Journal in 2013 that said that about 1% of formulas in spreadsheets have errors. And nobody checks these things. We don't have a VP of spreadsheets in our company that are checking these things. So it's becoming a bit of a problem. Next. Okay, so today, supply chains look very different from what they did in the 1960s. When these tools were developed in the 1960s, today is very, very different. And I think I can attest to this because I think I started working in about 1965, which is the date we've got there. And if you look at some of the characteristics of supply chains in that point, it was very, very low complexity. What's happened here? We've gone all the way back to a very small screen here. Okay. I can't really see the screen anymore. We've got multiple screens here. How does that happen now? Anyway, the world was very complex. And sorry, the world is now very complex. And then it was quite simple. Elaine, what's happened here? I can't. No, I can only see me now. Hold on. Oh, there we go. Okay. So supply chain complexity has become very high. Lives have become very short. Complexity has become very high, and customization has come very high as well. Longer lead times for parts, forecast accuracy has gone down. There's been a huge pressure for leaner inventories in our systems. So today's supply chains are looking very different than those that looked way back in 65, when the tools we use today were actually developed. So we need something for the new normal. Okay, next. Next. I'm not getting anything. Then can we have the next slide? Oh, you've got right back to the beginning again now. What's happened? Okay. Yeah, if you could just open that up to the presentation. So we've got a new normal now out there. Supply chains have become elongated and fragmented. The disparity means that holding stock somewhere strategically is an absolute must. Next. This means that planning horizons have become more remote from the actual demand realization. And also there are more products with shorter lifespans to manage. And many use common components. And this means managing stock positions effectively is a must if we want to manage our resources properly. This also means that detailed item forecasting is much more difficult. And if you press the next button again, we know that forecasts they're going to be wrong. Elaine, you can press the button. We know they're going to be wrong. The further out they are, they're going to be wrong. And the more detailed they are, they're going to be wrong. Okay, next. Okay, next. Now you're going backwards. Yeah, we're not doing very well here, are we? Go forwards. Okay. So we know that there are two universal points of inventory. If we're looking at a particular stock keeping unit, we've got A on the left-hand side where we have too little or we're out of stock, in fact. And then we've got B on the right-hand side where we really have too much for our current needs. And if you look at the dotted line that goes between those two, this is really the return on that investment that we're going to have in that inventory. And what we tend to find when we go and analyze warehouses, we tend to find that we get this bimodal distribution that you can see here, where we have a high hump of a number of SKUs on the A side and also on the B side. So we have too little of the right stuff and not enough of the wrong. We've got too much of the wrong stuff and not enough of the right stuff. And the optimal range sitting in the middle there, we have very few SKUs sitting in that particular range. Just hit the button again, Elaine. And this is an unhappy situation. And if you hit the button again, Elaine, what happens every time we run MRP, we get this oscillation from being, oh, we're okay, to being, well, we're not okay. And then we're back, we're okay again, and we're not okay. And so we get this flip-flopping from one side to the other, and most companies tend to report this. Next. So the bottom line effect is we have chronic shortages, and we have excessive inventories, and we have high expedite and expense costs. We're cross-shipping between warehouses, and we're flying freight in when we don't need to. But maybe the real problem's at a higher level, and it really comes from the bullwhip effect. Okay? Yeah, just hit the button there, Elaine. The bullwhip effect. Just hit the button again. Here we've got a little supply chain here. You can see we have a foundry and a component manufacturer. We've got a sub-assembler and an end item assembler. And if you hit the button again, yeah, we get this demand signal distortion going up the supply chains, and we get this supply continuity variability coming down the supply chain. And these bullwhips have been rushing up and down our supply chains for a number of years, and we've really had no way of mitigating it until now. And of course, the more parts we have in the supply chain, the worse this effect gets. But maybe the true solution must be we have to deal with this demand and supply distortion. We've got to try and work with it together. Okay, next. So if you look at the top here, we have demand signal distortion, which is giving us supply continuity variability. So it means the materials are not ready at the time that we need them. And why is that? Hit the button. There are 4 reasons, really. Signals with known error are used, which means we're using a forecast. Latent signals are used. Oversimplified signals are used. Well, latent signals mean that sometimes we only do our planning on a weekly basis. So in some cases, the information is a week old anyway. Oversimplified signals, a lot of companies have flattened their bills of materials in an attempt to try and improve their planning, and that's kind of been a mistake. And then changing and conflicting signals, because we think the customer wants 100, we send signals up the supply chain to make 100, and when we get the actual order, he wants 120, so everything has to change again. So if we fix the demand signal distortion, will the bullwhip effect be solved? No, it won't. Okay, next slide. Next. Okay. So what Carol and Chad have come up with is what we call the demand-driven MRP. It's a method to model, plan, and manage supply chains to protect and promote the flow of relevant information and materials up and down our supply chain. The DDMRP uses strategic decoupling points to drive supply order generation and management through a supply chain. And it was first articulated in the 3rd edition of Orlik's Materials Requirements Planning, which was published in about 2011, after 15 years of research. So this is not, as I mentioned, not something new. And Carol says she's standing on the shoulders of giants. We've had some great people doing some great stuff in our supply chains over the last 50 odd years. We've had Orlaki with MRP and DRP. We've had Ono and probably more recently Womack and Jones with Lean and Just in Time. Ellie Goldratt with Theory of Constraints. And Edward Deming with Six Sigma. All great tools, supply chain tools. And we're not throwing the baby out with the bathwater. You still need to use these tools in your supply chain. And if you don't know anything about them, I suggest you go out and find out something about them. Because we're taking the best out of these tools with some innovation, coming up with demand-driven materials requirements planning, in which we're going to position inventory correctly. We're going to protect that position so it never runs out of inventory, and we're going to pull in real time out of those positions. Okay, next. So there are 5 components of DDMRP, and the first one is positioning inventory correctly. It's a strategic decision as to where we're going to keep inventory. Secondly, we're going to protect that position. Okay, press the button. We're going to protect that position by with buffer profiles and buffer levels, and then we're going to do dynamic adjustment. Elaine, press the button. And once we have the first 3 positions in place, okay, we have our operating model in place. Elaine? Oh, there we go. Okay. Right, and then, okay, hold it there. All right, so the first 3 are putting in your operating model in your business. We're strategically positioning the inventory, we're correctly sizing the buffers, and then we're dynamically adjusting them because the marketplace that you're working in is continuously changing. And we don't want to have a static operating model. And so we want to be continuously adjusting this particular model. And then we're going to pull demand-driven planning in real time, and we're going to have visible and collaborative execution. Now, interestingly enough, traditional MRP does not have any execution attached to it. It's purely planning. With DDMRP, we have both planning and we have execution. Okay, next. So if we go back to our diagram we had before, strategically positioning the inventory, okay, why do we use latent signals? Because, press the button, we're using those weekly buckets. Why is it oversimplified signals being used? Because bombs have been flattened. Next. Got to keep going here, Elaine. Okay, why do we have all these things we called nervousness? Okay, because things have to change. When we get the actual order, it's different to what we forecasted, and we get this nervousness, and adjustments must occur as the actual demand becomes known. Next. So why does that happen? Because MRP is loaded with forecasts. And why do we load it with forecasts? Because the cumulative manufacturing and procurement times are much longer than the customer tolerance times. And MRP treats everything as being dependent. And why are materials not ready when they're needed? Because MRP plans are never properly synchronized. Supply variability transference causes delays and accumulates across the dependent networks. And so DDMRP plans, timing, and quantity requirements are built using all these dependencies. So the whole thing goes back to this bullwhip effect and not being able to manage our stock positions. Okay, so we want to be able to strategically position inventory in the supply chain. Okay, next, yeah. So if we go back to our original little supply chain there, and if you press the button, let's put a little buffer in between the component and subassembler. What happens is, as that demand signal distortion goes up the supply chain, it stops dead at the buffer. Yes, it starts up again until it hits the next buffer. And the same thing happens coming down. If we have a glitch in the foundry and they can't deliver the castings, as soon as that, because there's always inventory sitting in that buffer. And then, yes, it starts up again. So this stops the transference and amplification of variability in both directions where it matters most. So planning horizons are also shortened, as you'll notice there. Instead of having to plan that whole supply chain in one go, we're now planning it in two separate parts. Okay, so we're shortening that planning horizon and lead times. So yes, go on, carry on. Yes. So where do we place these strategic positions? And there are six placement considerations that we use in DDMRP. I'm not going to go through them in detail. You know, if you come on the 2-day course, the Demand Driven Planner course, we go into this in so much depth that at the end of the day, you can come away from that course and actually start applying some of these principles in your own business, maybe in just a small way to start with. But customer tolerance time, we need to know about. How long is the customer prepared to wait? What about market potential lead time? Maybe we're in a make-to-order business, and we give, as our competitors do, maybe a 2-week lead time for the parts that we manufacture for our customers. What if we could get it to the customer in 7 days or even 5 days? What difference would that make in our business? We could probably get a larger market share, maybe even command a higher price. Sales order visibility. How far in advance do customers generally give us orders? What about variability, both on the demand on the supply side? If it's very high, then that might be a very good position to be putting some sort of buffer. Inventory leverage points within our bills of materials. Are there sub-assemblies or mixes that might be worth buffering? And we have a whole technique around how to identify those items in your bill of materials that would benefit from buffering. Lastly, it comes straight out of theory of constraints and says that critical operation protection. You know, if you have a bottleneck or a constrained capacity, you always need to keep a buffer in front of that to make sure that it never runs out. Next. All right, so this was an actual example. If you look on the left-hand side, this is a make-to-order business, and they had an 8-week lead time. They implemented DDMRP, and you can see on the right-hand side, they put some buffers in there. They reduced their lead time down to their customer to 1 week from 8 weeks by strategically positioning inventory correctly in the supply chain. So hit the button again. The critical difference here is that MRP was never designed to decouple. It makes everything dependent, forcing longer planning horizons and variability accumulation. Next. Okay, so the second one is buffer profiles and levels. Typically, we have this 3-level buffer. We have a red zone, yellow zone, and a green zone. The red zone is basically the safety in the buffer. It's not safety stock, and it doesn't work like safety stock, but it's the safety we have in the buffer. And I think if you think of a buffer as a shock absorber, like on your car, it takes the shocks out of when we hit those potholes in the road, doesn't it? And the safety does the same thing, really. It just takes the shock out if we get a little bit of a bit of demand we weren't expecting. The yellow zone is basically the primary coverage in the buffer. And the green zone is really your order size and the order frequency. So you can hit the button again there, Elaine. Group settings and buffer profiles. We set up different types of buffer profiles, which are based on item types. So it could be a purchased item, manufactured items, distributed items, etc. And we would have different lead time and variability categories in there. Is it long, medium, or short lead time? Is it high, medium, or low variability? And we set up these buffers and then allocate every SKU to a particular buffer profile. So the system understands how to do the calculations. Then for each individual SKU, we need to know a few things like the actual lead time, the minimum order quantity, if it's significant minimum order quantity, and if it's a distributed item, in which location is it sitting? And then we need to get an idea of the average daily usage. And there are a number of ways in which we might want to determine that. And by understanding these things, we can calculate our buffers. Okay, next. So here we've got a buffer, and you can hit the button again. And we've got some data there. We can see this buffer. I'm not going to go through the calculations, but we've got a 300 order size. We've got a yellow zone of 357. And we've got safety in there of 233 units. And I think the critical difference here with traditional ways of doing things is that MRP was never designed to manage stock positions. It was designed to be the most perfect make-to-order calculator. Okay, and we've tried to manipulate it in other ways to try and use it for ways that it wasn't really developed for in the first place. And MRP nets everything to zero, whereas DDMRP never nets to zero. There should always be availability in your buffer. Next. All right, so the buffer is not like safety stock. It's not sticky tape. It's not fire extinguisher. It's more like a firewall, okay, stopping nasty things going backwards and forwards up and down the supply chain. Okay, next. So what's the third component of DDMRP? And it's all about dynamic adjustment. You know, in most ERP systems, we set it and we forget it. But our market's changing all the time. And if you look at that top diagram there, the black line is basically the average daily usage over a period of time. And it's gone from about 10 up to around about 50. And you can see as time has gone by, the buffer has expanded upwards. There's even a little point about 3/4 of the way along there that it dips down a little bit, where the demand went down a little bit, and so the buffer dipped down a little bit. Then it climbed up, and we're in a downwards trend now. But we can also put in, and by the way, those calculations, those buffer adjustments are done totally automatically. You don't have to do anything; it does it for you virtually on a daily basis. But on the other hand, we do have the ability to put in manual adjustments, okay? And here you can see we've got a bit of a season on this particular item, so it means we can go in and put a demand adjustment factor. So the critical difference is most conventional safety stock and reorder point systems, as I said, is static, not dynamic. Set it and forget it. Next. Now, this is a really elegant part, I think, of DDMRP, and it's the demand-driven planning. So we're moving away from planning on a forecast or a crystal ball to, next, to actual demand, all right? Actual demand, actual sales order. And a sales order is really pretty highly accurate compared to a planned order in an MRP system or a forecast. So it continues with a more relevant demand order generation equation. So there's only two new things we teach you in DDMRP, and this is one of them, and it's called the net flow equation. Okay, next. So net flow equation answers the questions that every planner is looking for every day. What's coming to me? What do I have? What demand do I have to fill immediately? And what future demand is relevant? And so we developed a new equation, a buffer status equation. We call it the net flow equation. Okay, at the bottom. And it is, what have I got on hand, plus what's coming to me, minus what's the qualified order demand that I need. Now, if that calculation puts you in the yellow zone, or we're still in the red zone, then we just reorder up to the top of green. It's as simple as that. If net flow puts you in the green, you do nothing, okay? Once it drops down into the yellow, we reorder up to the top of green. It's as simple as that. So hit the button. In your system, you'll get a to-do list for the day. Here's my to-do list. I've got one item that's in the red, and I've got 4 items that are in yellow that I need to replenish today. And it'll give you recommended replenishment orders to take you back up to the top of green again. So the system will give you a to-do list today in the correct order in which we should be doing it. Next. Okay, now what I would normally do here is go through this large simulation. If you press the button there, Elaine, you can see what happens. On the left-hand side, my supply orders come in, and on the right, the demand orders come in. And we've got a buffer here. And we will go through a simulation over a number of days, but we're running out of some time here. So just press the button again there, Elaine. And I think just press it again, because I'm not going to go through this. I'd only put a couple of days in. And again. Okay, now at the end of this simulation, you get a run chart basically that comes out, and you can see the blue line at the top there is really your net flow, and the black line, the dark black line, is your on-hand balance. All right, and if you press the button again, Elaine, you can see that the on-hand balances are now beginning to form a normal kind of distribution around this ideal range, rather than being too low on the one side and too high on the other side. And yeah, if we go through this demonstration, you'll see exactly how easily DDMRP works. But unfortunately, we don't have any time now. So next. Okay, now we also still use MRP in DDMRP, and that's why it's called DDMRP, but we use a decoupled explosion. So just press the button again there, Elaine. You'll see that these yellow items on here are those that are buffered. And what happens is that MRP starts up, and it'll go down to the next buffer and stop and wait until that buffer needs replenishing, and then it will start up again, which is a lot different to traditional MRP. If you press the button, which goes all the way down from top to bottom. On the left-hand side there, you see a normal MRP explosion goes from top to bottom. DDMRP, decoupled explosion, goes down until it hits a buffer, waits for that buffer to need to be replenished. In other words, net flows in the yellow, and it starts up again. Okay, next. Then we've got execution, and unfortunately I'm running out of time here. So it's giving us priority, but we tend to work on priority by due date. Sorry, not priority by due date, which is the traditional way MLP does things, but we work on priority by buffer status. So we're doing everything based on buffer status. We're looking at what needs to be done and putting it in buffer status order, which is much better than working on due date. Next. Okay, so what we're trying to do is move away from this bimodal distribution into a more normal distribution. Next. So DDMRP is proven to allow companies to plan and execute in this optimal range of strategically chosen points. Next. Okay, but this is only a very small part of what we're talking about. And if you look at them, just press the button again, Elaine. Okay, and again, and again, and again, and again, and again. Okay. If you look on, go back. Okay. If you look on the left-hand side, we've got our demand-driven operating model. And if you look, there are three buffers in there. We've got a stock buffer, then we've got a time buffer, and we've got a capacity buffer. We've just been talking about stock buffers. So if you're in a complex manufacturing environment, you might want to look at a more complex demand-driven operating model. And you'll see from the left-hand side, this being driven by actual demand. In the middle, we have a tactical demand-driven S&OP process, okay? And we also have a strategic process on the right-hand side, which is driven by market-driven innovation. And we now have a bidirectional process within our business, which we've never had before, from strategy, tactics, down to operations, and then feeding back from operations to tactics and feeding back into strategy as well. And if you come to Carol's presentation tomorrow at the same time, she'll be talking more about this bigger picture that you can look at. Okay, next. So some of the proven benefits have been that we find the main thing is customer service improvement, up to 97 to 100% customer service levels we've never really seen before. And at the same time, we're getting lead time compressions. We're getting lead times coming down. We saw that one example where one manufacturing company went from 8 weeks down to 1 week just by looking at ways of buffering internally in their business. It's about right-sizing inventory. Although we tend to find people have too much stuff, and generally we can reduce inventories, it's about getting the right size of inventory in your business and adjusting it according to the market demand. And also reducing costs, the lowest supply chain costs. And not only that, it's very easy and intuitive for the planners and buyers to operate this system. Okay, next. So I would encourage you to go to the Demand Driven Institute website. It's demanddriveninstitute, all one word, .com. And where I've circled at the top there, go and sign in, because you will then get greater access to some of the other tabs on the Demand Driven Institute, particularly the on-demand one, where you will get access into the last few Demand Driven World conferences, and you can listen to the case studies. Lots of case studies, lots of videos, etc. on here. Okay, next one. If you want more information, you can come and talk to us at Demand Driven Africa. We've got a stand here at the conference, and just press the button again, Elaine. Okay, and my contact details are on there, but just press it again, because what I want you to do. You haven't got my presentation. Okay, go back there one slide. All right, I put into my slide deck Carol's presentation tomorrow. Don't miss that. It's at 1:30, and after that, we've got a discussion in the Demand Driven Africa VIP lounge. You can come and ask Carol any questions you have or queries you have on the methodology. All right, and if you come to our stand, you can also got a chance to win her book or their book, Demand Driven Adaptive Enterprise, just by signing up for our newsletter, and we'll pick somebody out to win that particular book. So I don't think we've got time for any questions, have we, Colin?
No, unfortunately not, Ken.
Yeah.
But there was at least one question I saw with a couple of hands up in the audience. But what I suggest to those people is that they either send you a direct message on the system from the floor, or come and visit the Demand Driven Africa booth, where Ken and other members of the team will be available to help you. So finally, Ken, thank you very much. I apologize to the audience for those technical difficulties. Ken is normally a very slick presenter, and well done on managing a bad situation, Ken. Thanks very much, and a virtual applause.
Okay, thanks, Colin. Yeah, I do apologize, but I don't listen. You see, I should have listened to Jenny when she told me to use Chrome, and I am not using Chrome. So, and thank you to Elaine for advancing my slides. I do appreciate it. Thanks very much. Pleasure. Okay, thanks everybody, and come and talk to me if you need some more information, or come to our stand. Thanks. Okay, cheerio then.